Hi everyone, welcome to my channel. My name is Fikret. This video continues video series dedicated to learning Microsoft Fabric. In the past few videos, we have started discussion around Synapse Warehouse. One of the important activities in any warehouse, including Synapse Warehouse, is a data modeling. So today we are going to talk about data modeling in Synapse Warehouse. Let's get started. Here's a quick preview of what I'm going to cover today. We'll start with the discussion of data modeling basics, where we'll talk about importance of schema normalization, primary, foreign, and unique keys. Then we'll talk about benefits of primary, foreign, and unique keys in OLTP databases. Next, we're going to talk about data modeling in data warehouse. So modeling is done slightly differently in any data warehouse, including Synapse. So we'll talk about specifics. Next, we're going to talk about slowly changing dimensions. So slowly changing dimensions allows you to maintain change history to dimensions. So we'll consider different types of slow changing dimensions. I'll also explain what kind of extra columns to add to dimension tables to support certain types of slowly changing dimensions. Next, we're going to discuss how to build a relationship between facts and the dimensions. Again, that's done slightly differently than how you would do it for OLTP databases. In a demo section, we're going to go over the script that creates primary, foreign, and unique key constraints in Synapse Warehouse. And then we're going to explore using system views to get information about your existing constraints. Next, we're going to build relationship between tables, and there are a few ways of achieving that. You can do it either programmatically or you can do it from graphical interface. So we'll explore both options. Finally, we will wrap up our discussion with exploring some ways of generating unique values programmatically. Once you have determined certain columns as primary key, then you need to ensure that values inside these columns are unique. A quick reminder before we continue: if you are new to the channel, please take a moment and subscribe and hit notify button so that you could always receive latest videos from my channel. Thank you in advance. Let's get started. So let's talk about schema normalization, which is one of the basic concepts of data modeling. The data that you receive from source systems often comes in a mixed format. So, for example, in this sample, we have a trip data. And if we look closely, we have a mix of columns that could be classified as factual columns, like fare amount, passenger count. But there are also columns that describe these facts. So columns like city, payment type, trip date, and so on and so forth. So these columns you can also call dimensional columns. So when processing this kind of tables, it often makes sense to divide dimensional related columns into dedicated tables and keep factual columns in a separate table. So examples of this could be a schema like this, where you have only trip related columns here, and then all the geography related columns were moved to geography table. This is called normalization. And if you take fact tables and move all of the dimension tables in the dedicated tables and link them with the central table like this, you will get a picture like star. That's why this schema is called star schema. There are many benefits of normalization, including saving the space. So normalization also makes reporting easier. It also helps you to better maintain quality of your data, and it allows you to build data integrity rules in your schema, which we'll talk about a little later. Normalization requires that you identify identity columns for dimension tables, which is often contains sequential integer numbers. So in this example, we have geography ID column, and once you have moved all your dimension data to geography table, you can have dimension ID, which in this case geography ID column, to link these two tables together. Once you organize your data in this way, it makes sense to talk about primary keys, foreign keys, and unique keys. So what are the primary keys? Primary keys are unique indexes that you can create on your dimensional tables. It's often created on the identity column, so in this case it's geography ID. The foreign key, on the other hand, is a column that is pointing to primary key. So in this case, geography ID from trips table is a foreign key. When you're creating relationship in this way, we are talking about one-to-many relationship, because for each dimension ID, so in this case geography ID, you will have many rows from trips table which have the same geography ID. So what are the benefits of primary, foreign, and unique key constraint in OLTP databases? So primary and unique keys help you to enforce uniqueness, meaning that they will prevent inserting duplicate value to the column that is marked as primary key. So these keys also help you to improve performance of the queries. Foreign keys, on the other hand, help you to enforce data integrity. What I mean by this is that if you are trying to insert values into foreign key table that do not have matches in the primary key tables, OLTP databases will throw an error and would not allow you to insert incorrect data. Foreign keys can also help to prevent deletion of certain keys from primary keys if you have matches in the foreign key tables. Now, data modeling is a little different when it comes to data warehouse, and that's not only on Synapse data warehouse. Whatever I say here would apply to most of the data warehouses. So in many cases, it makes sense to denormalize tables. So what I mean by this, so in this example, we have normalized all the product related columns in the product. But as you can see, I have divided all the product category related information to separate table, whereas I have product model information in its another table. So this is also called a snowflake type of schema. Now your fact and the sum of the dimensions linked indirectly through intermediate table. So when it comes to warehouse, it's recommended that you get rid of some of these extra links, because extra tables and extra link would require extra join operations, which could be expensive in data warehouses. So in this example, it may make sense to collect all the product related columns inside the product table and get rid of these extra tables. So that will be one step towards denormalization. Another difference for data modeling is that data integration constraints are often not enforced. What I mean by this is that instead of creating hard constraint, which will control data integrity, you may want to control this on application level. Another difference is that dimension tables sometimes may contain change history. So we'll talk about this in a moment. And the related point is dimension tables may contain extra columns to support change history. And then if you implement change history, then table relationship between facts and dimension will be built slightly differently, which I'll describe shortly. Now let's talk about change history in dimension tables. Very often it's beneficial to store change history in dimensions. For example, if you have customer's residence location may change over the time. And it may be useful to capture this change from reporting perspective. So when you are capturing changes in your dimensions are called slowly changing dimensions. There are different types of slowly changing dimensions. One of the simplest option here is called type 1, where you simply don't maintain history. So that will be a good option for dimensions where you don't care about changes. In this case, your dimensions will always be overwritten. Another common type of slowly changing dimension is called type 2, where you add extra row versions representing new values in your dimensions. Because you are adding these rows to the table, so you can also view it as a change history maintained vertically. There are some other slowly changing dimension types as well. Some of them will contain change history horizontally instead of vertically. So I think they are less common, so I will not spend time on that. So here is how would you structure your type 2 SCD dimension table. So as you can see here, we have customer ID column, which you also call natural key. So that's something we have discussed earlier. But on top of that, you also add another key, which is often auto-incremented key. So that's what you call surrogate key. So surrogate keys allows you to maintain uniqueness while you have multiple versions of the same customer key. So in this example, you can see that customer's residence city has changed from Toronto to New York, and I have new version of the dimension added to the table. So customer ID for both of them will be same. However, customer key, which is again surrogate key, will be different. There are some other metadata columns that needs to be added for table to be considered type 2 dimensions. So here I have start date, end date, and is active columns, which reflect lifespan of each dimension. So whenever you have new version of the row, you expire the previous version of the row, as you can see on the screen. So the first version of the row have ended its life on this date, and from that date you have new version of the row which is active until some date in a distant future. Is active column will allow you to easily filter out all of the rows that are considered active. When you are building relationship of fact tables to type 2 dimensions, it's important to know that relationships should be built using surrogate keys rather than natural keys. So in this example, geographic key is my surrogate key, geography ID is natural keys, but as you can see here, I have placed geography key column from fact tables. So this is a key by which I am building relationship between these two tables. So building relationship this way ensures that you can always link version of the dimension that match to the fact row when this processing happens. All right, enough of the theoretical discussions. Let's jump into the demo section. All right, to demonstrate data integrity constraints, I'm gonna use SQL Management Studio and connect to sample warehouse that were created in the previous video. So this database has fully normalized schema. At the center of it, it's a trip table. So I have a sample of this data here. So you can see that it has some ID columns pointing to different tables, which we'll explore a little later. But it also has a factual columns, like fair amount, tax amount, so on and so forth. Let's first start with creating primary key. So I'm gonna switch to another script which I will be sharing in the description of this video. So my first command adds primary key to geography table. On the line 2, I'm assigning constraint name, and then here I am specifying key column. Notice that I am using not enforced clause here, which is mandatory when you are creating primary and foreign keys in Warehouse. And finally, my third command adds unique key to geography table. So syntax is similar, except I am using here unique keyword here. You can have only one primary key for each table. However, you can have multiple unique keys on each table. So let me demonstrate that. So in my next command, I am adding another unique key to geography table, this time on zip code BK column. My next command creates foreign keys on a trip table. As you can see, that syntax is pretty similar to primary key command, where I start by alter table command and specify foreign keys name, and then I specify a column from the parent table that serves as a bridge, and finally I specify table and the column to which my key will be pointing to. As I mentioned earlier, you can create more than one foreign keys. So my next command creates foreign keys pointing to the same geography table. However, in this case, I am using pickup geography ID column from main table. And finally, I have another example of foreign key pointing to the date table. Now, you might be asking, how do I know which columns have been assigned a primary or foreign keys? So if you are using SSMS, you will see your column icons changed in Object Explorer. So if I zoom in, you can see that icons for my geography ID column has been changed. Now you can also query a list of constraints using system views. So here I have few samples. So information schema table constraint command brings you list of all constraints on your table. So this query produces constraint name, table that this constraint name is placed on. So this is basically general constraint information. So we have another view called referential constraint. So if I query this, so this query produces list of foreign keys. So we have constraint name for that, and it provides a mapping to the primary or unique keys in other tables. So you can see that in some cases it points to primary keys, whereas in some cases it points to unique keys. So basically you can have foreign keys pointing to either primary key or unique key. So let's take a look at the next query. So key column usage. It provides more detailed information about your constraint. So it provides column level information for each constraint. So if your constraint have more than one column, you will see multiple rows for each constraint here. My next query is similar, so you can use both of them to get column level constraint information. Now let's talk about how to generate unique values for your primary and unique key columns. If you are familiar with other SQL database flavors like Microsoft SQL Server or Azure SQL Database, there is auto-incremental identity column feature. So the way it works, you specify certain columns as auto-increment columns when creating tables, and then these columns will be auto-populated without you worrying about that. So this is nice and convenient feature. Unfortunately, with distributed computing systems like Synapse Warehouse, that feature is not available. So you have to populate your unique columns using code. One way to solve this problem is to use the raw number function. To demonstrate how raw number function works, I have created a sample data. So let's take a look at this table. So let's say you are collecting geography information from some source. Over a certain period, you will get data sets like this, where you have different groups of rows. And for each group, you will have multiple versions of that. So in this example, we have row belonging to Toronto, and you can see that I have received one on May 24, another on the next day, and so on and so forth. Row number function allows you to number rows within each group. So let's say in this case, you can say this row will be assigned number 1, and this row will be number 2 and 3. And for next group, you will have similar numbering. And this function requires two key pieces of information. Partition, on which you divide your data. So in this case, it's city column. And then order by which you want to order your row. So in this case, it's date column. So let's take a look at the syntax from Microsoft documentation for raw number function. So as you can see, it requires partition by column, as well as order by clause. So if your purpose is to generate unique values on entire table level, then you can use a version of raw number function, which is much simpler. So let me switch back to SSMS. And as you can see here, I am using raw number function with over clause. However, I do not specify any partition by clause, which means that my entire table is a single partition. And for order by clause, select null command. So if I run this query, you will see geographic key column with unique values in it. One thing to notice that in real life data engineering tasks, generating unique values from source data is not enough. You have to also store the last generated unique IDs somewhere for each table, and then add them to the raw number function. So this is the techniques that I will be demonstrating in the next video. All right, now that we learned how to create data integrity keys programmatically, let's explore another way of creating this relationship, this time using a nice graphical interface from Warehouse portal. So I'm going to navigate to Warehouse portal, where I have opened the same sample warehouse, and I'm going to navigate to Model tab. So this presents me with the list of all the tables and views. So this is default view, but I can add another layout here. And then I can drag whatever tables I want to this layout. So I'm gonna bring trip table here, and then add geography table. As you can see, the relationship between these tables are shown immediately. So I'm gonna bring date table that we have created a foreign key relationship as well. Now if I browse my table, I can see that it has some ID columns pointing to other tables as well. So for example, pickup time ID. So I'm gonna bring time table here. Now I'm gonna create a relationship between trip and the time table. So in this case, we are looking to multiple to one relationship. So it's multiple on trip table side and one from time table side. To do that, I'm going to start from multiple table side. So this in this case is trip and pickup time ID column. I will select this and draw my mouse towards time tables time ID column and drop it here. And here I can change some settings, but for now it looks good. So you can see the cardinality from trip table is many to one, and from timetable side, it's a single. Optionally, I can also select assume referential integrity, which will create foreign keys for me. So I'm going to save this. Now we have relationship between these two tables. And if I go back to my system views and query my referential constraints view again, I can see that Fabric has added a foreign key constraints on my trip table. So its name is auto-generated name, and it points to unique key constraints created on the timetable. To recap, we can create table relationship using programmatic approach as well as a visual or graphical approach. It's more of personal preference as well as number of constraints you need to create for. If you need to create only few constraints, I would select visual ways of that. However, if you need to add constraints to many tables, I think using programmatic approach is more scalable and easier. So that concludes today's discussion. To recap, we have learned basics of data modeling in OLTP databases, explored different types of keys that you can create in these databases. Then we have discussed specifics of data modeling in warehouses, including in Synapse Warehouse. We have looked into different types of slowly changing dimensions. And then we learned building relationship between facts and the dimensions. So this discussion will pave way to further discussion where we will build end-to-end warehousing solution for Synapse. I hope this was helpful. Thanks for watching, and I'll see you in future videos.